Welcome to Creative World. In this video, we will learn about CPU scheduling algorithms in operating systems. We will discuss in detail 4 algorithms along with their theoretical concept and practical implementation in programming language. So, without wasting time, let's proceed towards the topic of the video. First of all, if we talk about the types of CPU scheduling algorithms, these algorithms are categorized into two major types. One is preemptive and other one is non-preemptive. Now these two types are further divided into sub 8 categories. Preemptive type algorithms are priority scheduling, shortest remaining job first scheduling, longest remaining job first scheduling, and round robin, while non-preemptive type algorithms are first come first serve algorithm, shortest job first, largest job first, and highest response ratio next. Out of these 8 types of scheduling algorithms, we will discuss shortest remaining job first scheduling, round robin, first come first serve algorithm, and shortest job first algorithm. Before going into depth of these algorithms, first of all we have to keep remember some time calculation formulas. The first formula is turnaround time, that is equal to completion time minus arrival time. Second formula is waiting time, that is calculated using this equation, turnaround time minus burst time. And third one is completion time, that is equal to arrival time plus waiting time plus burst time. So these formulas will be utilized while solving problems using these algorithms. So as we have discussed earlier, we will be discussing in this video these 4 algorithms. We will start from first come first serve, that is the type of non-preemptive algorithm. Name of this algorithm explains its working. The process which will arrive first, it will be served first. We will learn this algorithm with the help of an example. There are 4 processes whose arrival times are 0, 1, 5 and 6, and burst times of these processes are 2, 2, 3 and 4 respectively. Now it is required to calculate their completion time, turnaround time and waiting time. These times are not given in this scenario. I have calculated these times and mentioned here. So we will start solving this problem. We have 3 parameters: process ID, arrival time of each process and burst time of that particular process. Now we will solve this problem using Gantt chart. First of all, we will see in the queue process P1 is arrived at arrival time 0. It means it came first as compared to other processes. So it will be served first, as the name suggests, first come first serve of this algorithm. So first of all, process P1 will be executed. Now keep remember one thing, this is non-preemptive type of algorithm. So in this type of algorithm, if any process is chosen for execution, so it will completely execute and then next process will be chosen. While in preemptive algorithm type, a particular time of or particular cycles of each process is executed and then the next process is switched. After that, the particular cycles of that process is executed and then next process is switched. It means in preemptive type of algorithm, there are a lot of transitions from one process to another process, while in non-preemptive type algorithm, there is no transition between processes. Any process which is selected, it will completely execute and then next process will come. Now at this arrival time 0, P1 is came, so P1 will be executed, but how much is the burst time of this P1 is 2. So P1 will be executed for time 2. Now the CPU current time is 2. During the execution of P1, an other process arrived at arrival time 1. So the next first comer is P2 out of these three processes. So P2 will be selected for execution. Burst time of process P2 is 2. So it will execute for 2 cycles of CPU time and it will end upon 4. Now the current time of CPU is 4 and during the execution of process P2 up to 4, no other process arrived. So CPU will be free between 4 and 5 time. Now at time 5, an other process is arrived, process P3, whose arrival time is 5 and the burst time of this process is 3. Process P3 will be treated as first comer out of these two processes and it will be selected for the execution of 3 burst time and this process will end upon 8. Now the current time of CPU is 8 and during the execution of process P3 an other process is arrived on time 6. It is the last process and no one is after this process, so it will be treated as first comer and it will be selected for the execution. Process P4 have burst time of 4, so it will execute up to 4 cycles and will terminate on time 12. Now all of these processes are executed and their respective Gantt chart is developed with respect of time. Now we will calculate these 3 times from this developed Gantt chart. First of all, completion time will be calculated. We know that the completion time is that time of CPU at which a process is completely executed. For process P1, the completion time will be 2 because at this time the process P1 was completely executed. Similarly, for process P2, the completion time is 4 and for process P3, the completion time is 8. Similarly, process P4 is completed on 12. So the completion time of P4 will be 12. Now in order to find turnaround time, as we have discussed earlier, turnaround time is equal to completion time minus arrival time. So turnaround time for first process will be 2 minus 0, 2. For second process 4 minus 1, 3. For third process 8 minus 5, 3 and for last one process P4 12 minus 6, 6. Now we will calculate waiting time. Waiting time is equal to turnaround time minus burst time. So waiting time for process P1 will be 2 minus 2 equal to 0. 3 minus 2 will become 1 and 3 minus 3 will become 0 and 6 minus 4 will become 2. After calculating these 3 times, we are able to calculate average turnaround time that will be equal to the sum of all these turnaround times divided by the number of processes. 2 plus 3 plus 3 plus 6 divided by 4, it will become 3.5. Similarly, average waiting time will be equal to the sum of all these waiting times divided by the number of processes. 0 plus 1 plus 0 plus 2 divided by 4, it will become 0.75. Now we will validate this example with the help of programming language. I have developed a code in C language to execute first come first serve algorithm. So we will implement this same example with first come first serve algorithm that is developed in programming language. Here I have developed a code for the implementation of these 4 algorithms: first come first serve, shortest job first non-preemptive, and shortest remaining job first preemptive, and round robin. So for now we will validate only first come first serve. For the validation of this algorithm we will use same example which we have discussed earlier. So first of all we have to select any one algorithm out of these 4 algorithms using menu selection first come first serve algorithm. After the selection of menu item, it is showing that executing first come first serve scheduling algorithm. Now it is asking about the number of processes. So as we have discussed in example, there were 4 number of processes. Now it is asking for the first arrival time of process 1. So we can see that here first process is arrived on 0 time and burst time of this process is 2. So first process arrival time is 0 and burst time of first process is 2. Next, second process is arrived on 1 and burst time of this is 2. Next, second process is arrived on 1 and burst time of this process is 2. Third process is arrived on 5 and burst time of this process is 3. So third process arrival time is 5 and burst time of this process is 3. And last process arrival time is 6 while burst time of this process is 4. Arrival time is 6 and burst time is 4. You may see the results. This is the given data which we have provided to algorithm. P1 is arriving on 0 time and burst time of this process is 2. Subsequently, other processes are highlighted with their arrival time and their burst times. Now, after implementation of first come first serve scheduling algorithm, these are the outputs which we retrieved from this algorithm. Now we can counter check these outputs with our calculated outputs. So first of all, we will confirm completion time 2, 4, 8 and 12. 2, 4, 8 and 12. Turnaround time is 2, 3, 3, 6. Turnaround time is 2, 3, 3, 6. Next waiting time is 0102. Waiting time is 0102. Average turnaround time is 3.5 and average waiting time is 0.75. So average turnaround time is 3.5 while average waiting time is 0.75. We can also confirm the Gantt chart. First of all, process P1 was executed at 2 time. Next, P2 was executed up to 4 time. Next, P3 was executed up to 8 time. And then P4 was executed up to 12 time. So first of all, we have solved an example using first come first serve algorithm manually, and then those calculations are validated using first come first serve scheduling algorithm in programming language, and we can see that both results are identical. Now we will move towards next algorithm type. So next is shortest job first algorithm. Again, this is non-preemptive type algorithm. So we will discuss this algorithm with the help of an example. Now we have some processes that are from P1 to P4. Their arrival times are given and their burst times are also given. And we have to implement shortest job first non-preemptive type algorithm on this example to calculate their waiting time, completion time, and turnaround time. As the name of algorithm suggests, shortest job first. It means the shortest jobs or the processes with less burst time will be executed first as compared to other processes with higher burst time. So we will solve this example using this algorithm. First of all, we have to make Gantt chart. If we observe at time 0, one process is arrived P1 while the other processes are not yet arrived. So we will assume process P1 is the shortest job. So first of all, we will execute this process P1 up to time 8 because its burst time is 8. Now the current time of CPU is 8, and during the execution of this process P1, all of the other processes are arrived in queue, which are arrived at time 1, 3 and 4 respectively. Now CPU will implement shortest job first topology. Out of these 4 arrived processes, the shortest job is this process 3, which have burst time of 3. So CPU will select this process first to execute. So process P3 will be executed and it will execute up to 11 because the current time of CPU was 8 and burst time of this process is 3. So process P3 will complete at time 11. Now out of these two remaining processes, the shortest process is P2. So P2 will be selected for execution and it will execute up to time 15 because the burst time of this process P2 is 4. Now the last process is P4 and because it is the last process, so it will be considered as shortest job and it will be executed up to 9 burst time. So the process P4 will be executed up to 24. So in this sequence, the CPU implemented shortest job first scheduling algorithm for this example. Now we will try to find out waiting time, completion time and turnaround time. First of all, the completion time for process P1 will be 8 because at this time process P1 was completely executed. So completion time of P1 is 8, P3 is 11 because after P1 P3 was executed. P2 is 15 and P4 is 24. Now turnaround time is equal to completion time minus arrival time. 8 minus 0 will be 8. 11 minus 3 will become 8, 15 minus 1 will become 14 and 24 minus 4 will become 20. Similarly, waiting time will be equal to turnaround time minus burst time. 8 minus 8 will become 0, 8 minus 3 will become 5, 14 minus 4 will become 10 and 20 minus 9 will become 11. Now we can calculate average turnaround time and average waiting time using this formula, sum of all turnaround times divided by the number of processes. 8 plus 8 plus 14 plus 20 divided by 4, it will become 12.5. Similarly, average waiting time will become 0 plus 5 plus 10 plus 11 divided by 4, it will become 6.5. Now we will implement this same example in our developed program to see the results. So now for this time we will select option 2 for the implementation of shortest job first non-preemptive type algorithm. So select 2. After this a message is displayed executing shortest job first non-preemptive type algorithm. Now it is asking for the number of processes. So there was 4 number of processes which we have discussed in the example. Now we have to enter process 1 arrival time. So we will see the example what is the arrival time of first process. First process arrival time is 0 and burst time is 8. Arrival time is 0 and burst time is 8. Second process arrival time is 1 and burst time is 4. Arrival time is 1 and burst time is 4. Third process arrival time is 3 and burst time is 3. Arrival time is 3 and burst time is 3. Fourth process arrival time is 4 and burst time is 9. Fourth process arrival time is 4 and burst time is 9. Now the implementation of SJF algorithm is done. You may see the data which we have provided to the code. Given data is P1 is arriving on 0 time while the burst time of this process is 8, and similarly for rest of other processes their arrival times and burst times are mentioned. Now after the implementation of SJF algorithm, these are the output results. So we will validate these results with our calculated values. P1 completion time is 8, P1 completion time is 8, P3 completion time is 11. So you may see here P3 completion time is 11, P2 completion time is 15 and P4 completion time is 24. P2 completion time is 15 and P4 completion time is 24. Now turnaround time is in same manners 8, 8, 14, 20. Turnaround time is 8, 8, 14, 20. Similarly, waiting time is 0, 5, 10, 11. 0, 5, 10, 11. Average turnaround time is 12.5 and average waiting time is 6.5. So average turnaround time is 12.5 and average waiting time is 6.5. Gantt chart of this algorithm can also be validated. In this Gantt chart, first of all, process P1 is executed, then process P3, then P2 and P4. You may see here first process P1, P3, P2 and P4 are executed respectively. So next algorithm is shortest remaining job first algorithm, and it is the preemptive type algorithm. As we have discussed earlier, in preemptive type algorithm there is a transition that occur between processes. So one thing we have to keep remember, there will be transition that will occur between processes. The name of this algorithm is showing the working of this algorithm. Shortest remaining job first means first of all we will make a transition. Okay, after that transition the shortest remaining job will be executed first, and then out of the remaining jobs the shortest remaining job will execute then, and so on. So we will learn this concept using an example. I am following this example. In this example, 4 processes are arriving on CPU at time 0, 1, 2 and 3 with their bus times 8, 4, 9 and 5. Now we have to implement shortest remaining job first preemptive type algorithm on this problem and find turnaround time, waiting time and completion time. So first of all we will solve this problem with the help of Gantt chart. If we see before time t0 no process was present. At time t0 a process occur p1, okay, and its bus time is 8. So what will happen, this process will be considered as shortest job, so it will be executed at time 0 and only one execution will occur of this process up to time 1. After that at time 1 another process is arrived whose bus time is 4. Now out of these two processes the shortest job is P2. So rather than executing P1 completely, the CPU will shift to process P2. So P2 will be executed for 4 times. Its completion time will be 5. Now the current time of CPU is 5 and during the execution of P2, two other processes are also arrived. One of them is process P3 whose bus time is 9 and it is arrived on time 2, and other process is P4 whose arrival time is 3 and bus time is 5. Now CPU will examine out of these 3 processes which one is shortest. So the process P1 is 7 because its one bus time is executed and 7 bus times are remaining, while process P3 is 9 and process P4 is 5. So out of these 3 processes P4 is shortest. So P4 will be executed first and it will be executed up to 5 bus times. So it will complete at time T10. After the completion of process P4, now out of these two processes the smallest or shortest process is P1 because its remaining bus times are 7 while P3 is 9. So first of all the shortest remaining job will be executed. So out of these two processes P1 is shortest. So P1 will be executed first and its execution will be up to 7 bus times. It will complete at 17. Only process P3 is left. So P3 will be executed for 9 bus times and it will complete at time 26. Now we will try to find out unknown parameters. The first one is completion time. So we will start from P1. P1 was started here but it is completed here. So the completion time of P1 is 17, P2 is 5, P3 is 26 and P4 is 10. After finding out the completion time, we are able to calculate turnaround time, that is equal to completion time minus arrival time. 17 minus 0, 17, 5 minus 1, 4, 26 minus 2, 24, 10 minus 3, 7. Now we can calculate waiting time, that is equal to turnaround time minus burst time. So turnaround time is 17 minus 8, it will become 9, 4 minus 4 will become 0, 24 minus 9 will become 15, and 7 minus 5 will become 2. Now we will validate this example with the help of developed program by implementing shortest remaining job first. So move towards the program. Now we will implement shortest remaining job first preemptive type algorithm. So we will choose option 3 from menu. After that, it is asking for the number of processes. As we have discussed in example, there was 4 number of processes. Now it is asking for arrival time and burst time of each process. So first process arrival time was 0 and burst time was 8. Arrival time is 0 and burst time is 8. Next process arrival time is 1 and burst time is 4. Arrival time is 1, burst time is 4. Next process arrival time is 2 and burst time is 9. Arrival time is 2 and burst time is 9. And last process arrival time is 3 and burst time is 5. Arrival time is 3 and burst time is 5. Now after implementing the shortest job first preemptive type algorithm, these are the output results which we retrieved from the developed code. We will validate our output results with our calculated results. So first of all, we will validate completion time, that is 17 5 26 10. 17 5 26 10. Similarly, turnaround time is 17 4 24 7. Turnaround time 17 4 24 7. And waiting time is 9 0 15 and 2. Waiting time is 9 0 15 and 2. Similarly, we can calculate the average turnaround time, that will be equal to the sum of all these turnaround times divided by the number of processes, that is 13. And average waiting time will be equal to sum of all these waiting times divided by the number of processes, that will become 6.5. So average turnaround time is 13 and average waiting time is 6.5. Average turnaround time is 13 and average waiting time is 6.5. We can also justify Gantt chart at time t0. P1 is executed, after that P2, P4, P1 and P3. P1, P2, P4, P1 and P3. And you may see that here some transitions are occurring between processes. This shows the nature of preemptive type algorithms. Now we will move towards the last algorithm, that is round robin algorithm. And again, this is the preemptive type of algorithm. It means there will be transitions between processes. So we will learn about this algorithm with an example. Here is the example. There are 4 processes that are arriving at time 0, 1, 2 and 3 with their burst times 10, 9, 12 and 6. And we have to implement round robin algorithm on this example. So first of all, we know that in order to do round robin algorithm, we have to specify another parameter, that is quantum time, and it is actually the predefined time for which every process run, and after the completion of this time a transition occur to next process. In order to implement round robin algorithm, we have to make a Gantt chart, and other one is ready queue. This ready queue contains the next process information which will execute after transition occur or after the completion of current quantum time. So start from here. Before time 0, no process was present. At time 0, one process is arrived whose burst time is 10. So first of all, this process will be executed. In ready queue, P1 will come, which is arrived at arrival time 0. So P1 will be executed because none of other process is available at time 0. But as we have discussed earlier, this process will execute for only 4 times because the quantum time is 4. So P1 will be executed for 4 times. So after the execution of process P1 for 4 times, now the current time of CPU is 4, and at this time 3 other processes are also arrived with time 1, 2 and 3. So during the execution of 4 times of P1, we can say that 3 other processes are also arrived in this sequence. P2 is arrived first, then P3 and then P4. So all of these processes will be executed in next, so they will be placed in ready queue. First of all, P2 is arrived, then P3 and then P4. So as we discussed earlier, after the completion of quantum time, a transition is occurred. So P1 will be shifted here, and now in ready queue the next process is P2. So P2 will be executed for 4 times. One more thing to keep remember, P1 was executed for 4 times, so the remaining burst time of P1 is 6. Now P2 is being executed for 4 times and the burst time of P2 is 9. So P2 will be executed up to 4 times and the remaining burst time of P2 will be 5. After the completion of quantum time, this process P2 will be shifted into ready queue and next process will be executed. So P2 is shifted in ready queue and next process is P3. So it will be executed for 4 quantum times up to time 12. Burst time of P3 was 12. So after the execution of 4 times, the remaining burst time is 8. After the completion of 4 quantum time, P3 will be shifted into ready queue and P4 will be executed for 4 times. Burst time of P4 is 6 and it will be executed up to 4 times. The time will be 16, and after the execution of 4 cycles, P4 burst time will remain only 2. Now P4 will be shifted into ready queue and next process is P1. It will be executed for 4 times. So it will come here and it will execute up to 4 times. Now the remaining burst time of P1 was 6 and it will execute up to 4 times as specified by quantum time. So it will run up to time 20 and remaining burst time of P1 will become 2. And it will be shifted into ready queue and next process P2 will be executed for 4 times. P2 remaining burst time was 5. So after the execution of 4 process time, it will remain only 1 and it will be shifted into ready queue and next process P3 will be executed. P3 remaining burst time was 8. So after the execution of 4 times, its remaining burst time will remain 4 and it will transit into ready queue after time t28. Now P4 will be executed because it is the next process in ready queue. So it will be executed. Now the remaining burst time of P4 was 2 but the quantum time is 4. So it will execute for only 2 times up to 30. And it will finish. Its remaining burst time is 0. So P4 is completed. So next process is P1. It will be executed for 4 times. Remaining burst time of P1 was 2. So rather than 4 times, it will execute for only 2 times. It will execute from time 30 to 32 and it will finish because remaining burst time will be 0. Now the next process is P2. It will execute. P2 remaining burst time was only 1. So it will execute from 32 to 33 and it will also finish because remaining burst time is 0. Now next process in ready queue is P3 and it will execute for 4 times and it will end on time 37 because its remaining burst time was 4. So out of 4, remaining burst time will be 0. At this stage, all of these processes are executed and their respective Gantt chart is developed here. You may see here multiple transitions are occurring between processes. This shows the nature of preemptive type algorithm. Now we will find remaining times from this Gantt chart. First of all, we will find completion time. So process P1 is completed at time 32. Process P2 is completed at time 33. Process P3 is completed at time 37 and process P4 is completed at time 30. After calculating completion time, we are able to calculate turnaround time, that will be equal to completion time minus arrival time. 32 minus 0, 32, 33 minus 1, 32, 37 minus 2, 35, 30 minus 3, 27. Similarly, waiting time can be obtained by subtracting burst time from turnaround time. 32 minus 10 will become 22, 32 minus 9 will become 23, 35 minus 12 will result 23 and 27 minus 6 will become 21. Now we can calculate average turnaround time, that will be equal to sum of all turnaround times divided by the number of processes. It will become 31.5. Similarly, average waiting time will be equal to 22.25, that is equal to the sum of all waiting times divided by the number of processes. Now we will implement this same example in developed code. So we are here on our developed code. Now at this time we will select option 4, round robin implementation. Okay, it is showing that executing round robin preemptive type algorithm. Okay, it is asking for the number of processes. As we have discussed in example, there was 4 number of processes. Okay, after entering the number of processes, now we have to enter the arrival time and burst time of each process. So the arrival and burst time of first process is 0 and 10. Arrival time is 0 and burst time is 10. Next, arrival time of P2 is 1 and burst time is 9. Arrival time of process P2 is 1 and burst time is 9. Next, process P3, arrival time is 2 and burst time is 12. Arrival time is 2 and burst time is 12. Next, process P4, arrival time is 3 and burst time is 6. Arrival time is 3 and burst time is 6. And as we have discussed in the example, quantum size was 4. Here it is showing the given data which we have provided to program. P1, P2, P3 and P4 are arriving at 0, 1, 2 and 3 with their specified burst times and quantum time is 4. After implementation of round robin preemptive type scheduling algorithm, we get these results. We will justify our calculations with these results. So first of all, P4 completion time is 30, turnaround time is 27 and waiting time is 21. 30, 27 and 21. Here we can see that P4 30, 27 and 21. Next process P1 completion time 32, turnaround time 32 and 22 waiting time. P1 completion time 32, turnaround time 32 and waiting time 22. Next, P2 completion time 33, turnaround time 32 and waiting time 23. Process P2 completion time 33, turnaround time 32 and waiting time 23. And at the end, process P3 completion time 37, turnaround time 35 and waiting time 23. Process P3 completion time 37, turnaround time 35 and waiting time 23. Okay, after that we can also confirm average turnaround time and average waiting time, that is 31.5 and 22.25 respectively. So average turnaround time 31.5 and average waiting time 22.25. We can also confirm Gantt chart. You may pause the video and confirm Gantt chart which we have developed and which is developed by the program. Both will be same. Here is the Gantt chart developed by the program. So this was all about CPU scheduling algorithms. In this video we have discussed four types of algorithms. First come first serve algorithm, which is non-preemptive type algorithm, and shortest job first algorithm, which is also non-preemptive type algorithm. In another part, we have discussed round robin and shortest remaining job first algorithm. Both of these are preemptive type algorithms. Thank you. See you again in next video.